Hi everyone. So this relatively short video is designed to go over the final project. So the things that we're going to go over are safety, teams, a brief overview of the project, the lab periods that you have to do the project, the pre-lab, and the grades. And again, this is just meant to be a very brief presentation. It's really important that you also read through the project overview for many more details than you're going to find here. So the first thing I want to go over is safety. So as always, you need to wear all of your personal protective equipment. Okay, you will be using for the pH section concentrated sodium hydroxide, which will be diluted to do to some titrations. And this is very dangerous, especially if you get it in your eyes. So we're wearing gloves, goggles, and a lab coat at all times. And if it gets spilled, we're going to clean it up. Make sure that you dispose of the chemical waste in the proper waste container. If you're not sure, please do ask your TA if it should go in the waste container, because we are going to be using things like sugar, which can go down the sink. But we're also going to be using things like KHP, potassium hydrogen phthalate, which cannot. So just make sure that you ask if you're not sure. And then finally, no unauthorized experimentation. If you're not sure if you should do something, please check with somebody before you actually do it, just because we don't want to mix the wrong two things together. Most of the stuff in the lab is compatible chemicals, so that's fine, but we especially don't want to be mixing concentrated sodium hydroxide with things and things like that. So if you're just not sure about doing something, please just ask before you do it. So how the project will be working is that each class will be broken into teams of 4 students. Now, if you don't have 16 or 20 students and you can't have an even number of all the teams being 4, we will break it up so that there's the smallest possible number of teams of 5. The project is really designed for teams of 4, so basically for 20 students to have 5 teams of 4, but we understand not all sections have 20 students, so there may have to be some teams of 5. If that happens, you're going to have to decide how to break up the workload. Teams are absolutely required. There's no possible way that a team of 2 or 1 person could do all of this work, so please break up into teams of at least 4, and again, there may be some teams of 5. So the idea here is for each team to develop a flavor of Danerade. So what you're going to do is you're going to essentially make calibration curves for most of the sections, everything except pH, and then you're going to determine the concentration needed to make your specific flavor of the compound. So for example, you want to have a density of 1.045 if you're in team 1 and you have to make the flavor Blue Storm. So you would make a calibration curve of concentration versus conductivity, or excuse me, versus density, and then you could figure that out, what exact concentration will be for this particular density. You do the same thing with electrolyte conductivity using sodium chloride, and then dye using the absorbance, and then the pH. The pH is a little bit new, so I do want to talk about each section. But before I do that, I just want to remind you that a guess and check method isn't going to work. You can't just start mixing things together and then measure their density and their electrolyte conductivity, their absorbance, and their pH. Also, at the end of the day, you're actually going to make your solution based on the recipe you develop and then test it and see if it's close to what you would expect. If it's not close to what you would expect, you want to explain why. So that's basically how this is going to work. So for each of the sections, I do want to give a brief overview. So for density, you're going to make a calibration curve of sugar concentration versus the density. So you're going to make a bunch of different concentrations of sugar, and then you're going to measure the density. This is very similar to experiment 3 of General Chemistry 1, if you want to look there for details. And generally speaking, how you would do this is if you have a team of 4, each of the 4 people would be assigned to one of these things. That being said, you are responsible for this as a team, so if you're stuck, please ask your teammates. Also, of course, you can ask the teaching assistant as well. Conductivity, you're going to use the conductivity meter in the microlab, and you're going to make a calibration curve of concentration versus conductivity. So the concentrations of several solutions will be known, and then you're going to measure their conductivity and make a calibration curve. And this is very similar to experiment 2 of the general chemistry lab manual. I will note that your conductivities are significantly lower than what were expected for experiment 2, so you are going to need to make significantly lower concentration solutions than you found in experiment 2. dye. You're going to make a calibration curve of conductivity versus absorbance. You did this for red food coloring to determine the concentration of an unknown. So you're going to go ahead and make that calibration curve using your specific dye. Notice that different teams are using blue 1, blue 2, yellow 5, so on and so forth. So you can make different calibration curves based on the dye that you have. And then you're going to make the calibration curve similar to experiment 14, and then you're going to use the absorbance that you're provided. Okay, in this case, this is the absorbance that you want your Danerade solution to be. So you're going to use this absorbance to then back calculate the concentration that is required. So that is basically how that works. pH. The pH is one that you haven't exactly done. So you're going to determine the pH, or the Ka, excuse me, of ascorbic acid by titration and pH. So ascorbic acid is vitamin C. So you're going to determine the concentration of ascorbic acid similar to experiment 8 and really similar to experiment 9 as well, except in 9, instead of finding concentration, you actually found the molar mass, but it's still very similar to experiments 8 and 9 in the way you're going to do the titrations. Then you're going to use the concentration and the pH to mathematically determine the Ka. So that is very similar to questions in the chapter 14 homework that you're going to have due coming up. So you can see how to use the pH and the concentration in order to find the Ka. So just be aware that that's basically what you're going to do. Then using the experimental Ka that you found, not the looked up Ka, you're going to determine what concentration of ascorbic acid solution you're going to need to make this specific pH. Again, after you make all of these, in these three cases, calibration curves, in this case, pH and concentration measurements by titration, you're going to measure the concentration. You're going to then go ahead and make your Danerade solution and then test all these things. Test the density, test the conductivity, test the absorbance, and test the pH. And then you're going to compare what you expected to get to what you actually got. Now, I'm going over this in 3 or 4 minutes. This is not enough time to go through all the details of these things. Please do see the full experiment overview, the project overview, in order to get far more details than you've gotten here. Also, if you have questions, please come to office hours and we're more than happy to help. So most of the sections that I just talked about were done in a single lab period, right? So you could theoretically get this all done in one lab period, but you have a little bit longer than that to do this. That's not to say you have so much time that you can't start getting to work. So it's really important to get to work on project day 1. So on project day 1, the TA will give you a brief introduction and answer any questions you have. You're also going to hand in your pre-lab, which I'll talk about in the next section. And if you have any questions, please do come to office hours. After you have a little time with the TA at the beginning of class, we strongly recommend you start getting to work on project day 1. Now keep in mind, you will not be able to save any solutions between lab periods, because we don't have a good way to save thousands of solutions that could be made from all you guys. So basically, just be aware that you need to get your work done in that single lab period, because they can't be saved. But it's a good idea on project day 1 to run through the experiment. Hopefully it'll all work. But if it doesn't work, then you have project day 2 to fix any problems that there are. So maybe you'll finish 2 or 3 out of the 4 sections, and you'll have another section or 2 or 3 even that you have to still work on. But you can get quite a bit of work done on project day 1, and most importantly, you can learn where there's problems. Then you can go ask somebody, go to office hours and ask, and then have a plan for project day 2 to correct any problems. So I would strongly recommend trying all 4 of the project sections on project day 1, with each student doing 1 section. Then project day 2, fix any problems where things don't work. Project day 3, you will have a little bit of time to finalize any details of the project, but most of the time students spend the first half of project day 3 working on their presentations. And then after an hour and a half, you'll give a practice presentation. The TA will give you some feedback, and then You'll have a draft of your presentation essentially when you leave, and then you'll give your final presentation on project day 4. Note that this is a very, very low stress environment to practice your presentation. You'll be around 20 other students, okay, and a TA. So this is a very low pressure environment to give a presentation, and giving presentations is important. So it's a good idea to get some practice with that. So this is basically how it works. The first 2 days, you do the chemistry work. The third day, you work on the presentation. The first hour and a half, write the presentation. The second hour and a half, give a practice presentation. And then the final presentation is the last day. I should also note that the lab report will be due the day that you give the final presentation. The pre-lab will be due on project day 1. And I'm going to talk about the first day pre-lab now. So the first day pre-lab, you're going to have at the beginning of the first lab. And we want to strongly encourage you to work as a team to complete this pre-lab. We completely understand that each person in the team will be assigned to one section of the project and will primarily write that pre-lab. But it is a good idea to share it with your teammates and make corrections and things like that, and then put it together into one pre-lab document. We strongly encourage you to do that because working in teams is something that we all do all the time in real life, and it's a good skill to practice. So we encourage you to do that. So the pre-lab is mostly a usual pre-lab with an objective, a hypothesis, an experimental procedure, a variables, and a chemical hazards and waste. And as we mentioned a little while ago, most of these experiments that you're going to be doing are very, very similar to experiments you've already done, with the possible exception of the KA, which has that one little extra step that is the math from chapter 14. So that's normal pre-lab. But there is an extra requirement for the pre-lab, which is the introduction. And the introduction will be about 300-word introduction on top of, before, if you will, the usual pre-lab. And the reason we're having you do the introduction is just to get a little bit more familiar with the specific part of the lab that you're going to be responsible for. And I know that this pre-lab is going to be some extra work, but on the plus side, you only have one pre-lab for the entire project. So you have 4 project days, but you only have one pre-lab. So it's not like you have to do this every week, you just have to do it the one time. So how are you going to write the introduction? Well, for each section, okay, sugar, electrolytes, dye, and pH, we've given you some ideas of how you might craft your 300-word introduction. Essentially, you can answer these questions. But when you answer these questions, what you want to do it in is paragraph form. So you don't want to just write, the question and then the answer and so on and so forth. You want to use these questions as kind of guidance to draft a 300-word, one-page-ish document about your specific topic, whether it's sugar, electrolytes, dye, or pH. And again, we fully intend that each student will be responsible for one of these 4 sections. If you have 5 students, the pH one is probably the most work, so you might want to put 2 people on the pH section because it is new, a little bit new compared to some of the other sections. So that is basically how you're going to write the introduction. So again, your pre-lab is the usual thing, objective, hypothesis, procedure, variables, chemical hazards, and waste, and the introduction, which obviously will go before those things. So you're basically writing your usual pre-lab plus an introduction. It will take you a little extra time the first week, but you will not have to do it again. So the last thing I want to talk about is grades. So the lab report consists of the pre-lab, which is due the first day, and then the lab report, which is due the last day. And the lab report is essentially just going to have your data in it, all right, your calibration curve in most cases, as well as your actual Danerade that you made, and then a brief conclusion that explains how the Danerade solution you generated differs from the recipe that you came up with, if it differs at all. Maybe it'll be exactly what you expect. Maybe the absorbance and the density and the conductivity and the pH will be exactly what you'd expect, but if they're not, an explanation of why they're not, and chances are they're not going to be, for reasons that it's too early to discuss at this point. So that will be your lab report. Okay, and that will be due the day that you give the presentation. Precision and accuracy. We expect calibration curves that are straight lines, r squared of 0.99 or better. If your r squareds aren't good, you need to redo it. That's why it's really important to get to work on the first day of the project, because if there are any mistakes, you need to get those ironed out the second day of the project, so that you can use the entire third day of the project to write your presentation. So you don't have to write the presentation on your free time. You can do it during the third day of the project. All right, so we do expect that things to be close to expected values, and we expect things to have low RSDs if you're doing titrations, and we expect your R squared on your calibration curves to be 0.99 or better. So you need to make sure that you are collecting good data and you're working carefully. Presentation. Okay, so you will have the opportunity to give the presentation, and everybody needs to talk during the presentation, so you're going to have to decide how to even out the presentation. Basically, each person will talk about the section that they did, and we would like to see some improvement between the practice presentation and the final presentation. That's a good opportunity for you to get some feedback, and maybe the TA will say, oh, you forgot to talk about this, or you might want to change this slide, or so on and so forth, and then you just take those into consideration, and you make those changes, and you do that on your final presentation. It shouldn't be major, huge things. It should just be, things to kind of, polish the presentation, if you will. And then finally, participation. It's really important that every group member pulls their weight. So part of the grade is basically an anonymous survey, okay, that basically lets people, grade their teammates, and as well as what the TA thinks about what's going on. So that's basically that. All of these things are worth one lab report grade, right? Because there's 4 days and there's 4 different grades. So you can get A, B, C, D on this, A, B, C, D on this, A, B, C, D on this, and A, B, C, D on this. It's very low pressure, all right? So we're not telling you that you don't need to freak out or be worried that you're going to get a bad grade in one of these things or whatever. What's important is if you come in and do what you're supposed to be doing and make an honest effort, you're going to do fine. So don't. This is not designed to make you scared or give you a lot of pressure or anything like that. It's just a common question that we get, so I did want to go over it very briefly. So this is basically a project that gives you an opportunity to put some of the things that you've learned into practice. Okay, the people at Gatorade, okay, do use these kinds of techniques, and other food companies use these kind of techniques to make things be the right color that they want, have the right concentration of electrolytes, or have the right concentration of sugar in them, and all these kinds of things are actually done in the real world. Now, the project is a little bit made up, all right? It's not exactly, some of the things you couldn't actually drink, so do not drink your Danerade solution. But basically, these are just important overview or experience working in groups, developing methods for doing things, presenting on what you did, and working as a team to accomplish a goal. So we hope you enjoy the project, and thanks for watching the video.